Okay, so we're going to be transforming quadratic functions. And I will say that this feels more complicated than it actually is. So I'm going to do my best to present it to you guys to show you that we're not actually doing much at all. Like, the questions themselves are crazy simple if you understand it, if you understand what's being asked. But I know in past years, the topic itself kind of, you know, I'm not sure what the reason it feels scary is. I'm sure it's partly having to do with like whether it's an x, the x squared itself just feels more complicated. Yeah, who's got a question? Sam. Do you guys keep turning each other's mute on and off or something? Okay. So what I wanted to do first was I wanted to go over graphing x squared. This is going to be called a parent function. And we're going to base the other ones off of it. So if you know what x squared looks like as a graph, you can graph the other ones super fast. Who should we go with? We should go with... Oh, Max is on today too. Max, did you have a preference for how you wanted to do class when I got back? Do you prefer live or do you prefer recorded? Like, need to take attendance by a certain time type thing? Yeah, right. Good talk, Max. Okay, I was going to call on somebody. Let's go with Kirby. Kirby is super excited to be the first person called on today, and she's really happy about it. I can tell. Kirby, are you ready for your question? Okay, excellent. Can you tell me anything about what x squared looks like? Do you remember what it looks like as a shape? Okay, so from the last couple days, do you kind of remember what the graph cell looked like? Okay. Take your best shot at describing it. Yeah, you can look back. That's for sure. I'm not even looking for detail. I just, Perfect. That's what I was looking for. So every quadratic function, x squared, will look like some form of a u. Now this u shape can be changed. The u could be skinnier, it could be wider, it could be upside down, it could be up or down. Those are the transformations that we're talking about. Ben, you got a question? Oh, no, okay. So regular x squared has its vertex at 0, 0. That is not black. So the parent function starts there. And then you kind of memorize these points. The next point is 1 over 1 up. And then the next point is 2 over 4 up. Because you square it. 2 squared is 4. And it works that way on both sides because it's symmetric. Okay, so these 5 points make the U shape. So this is called the parent function. Because all of our U-shaped graphs can be based off of this one. And I know that that's not the greatest U shape you've ever seen, but we'll go with it. We'll pretend it's awesome. Now I'm going to graph this first one for you and see if you can figure out what the change actually is. Okay. So if you guys have colors, like if you have colored pens or pencils or something, it might make it super easy in your notes if you do colored like this. But if not, whatever, So the red one. Oh shoot, it's off the top. The red one would look like this. This is a lot harder to draw than it should be. I'm not coordinated enough to try drawing greatly without looking where I'm drawing. Okay, so that's what this red one would look like. That's A. So this red one is 3x squared. Oh, sorry, somebody wrote something up here. It's probably Max. No, it wasn't. Oh, that's fine, Sam. Like if you guys need to go to the bathroom and stuff like that, it's fine. You just tell whoever's subbing that day. Austin, what can you tell me about the red one? How is it different than the black one? So it doesn't. I just did a really bad job trying to draw it. Like they're both at 0, 0. It's really hard to draw on a tablet like this. If you had to describe what it looked like to somebody, how would you say it's different from the black one? It's okay if you're not sure. I can pass it on to somebody else. Not a problem. Okay, no problem. Honey, how would you describe the red one compared to the black one? Like if you're looking at this picture and trying to tell somebody what the difference is. Okay, that's all right. That's not a terrible description, to be honest. I understand that one. I honestly, I was expecting somebody to say the red one looks skinnier, which I know is not a great term. The technical answer is it's 3 times taller. So I'm going to accept either one of those two answers. So if you have to describe the transformation from x squared to 3x squared, I would accept that you would say it's skinnier. I would also accept the fact that you would say it's 3 times taller. Okay, so the 3 being multiplied in the front made every point go up taller. And so, honey, when you said it's bigger, I mean that's technically true because it is. It's taller. Okay, B. If I were to graph B, it would look like this. Oh, my drawing skills are subpar. So it would look like that. Sydney. Sydney, how would you describe the purple one compared to the black one? Okay, wider is absolutely one correct answer. Can anybody think of the technical one? So like using numbers. That's what technical would be. Like trying to describe it with numbers. I don't want to call anybody, just, is there anybody who thinks they know? The purple one? Okay. I'm thinking you have it backwards, or try to say it backwards. Basically, the purple one is half as tall. Or you can say it's 2 times shorter, but most people don't like to do that one. So the purple one is half as tall as the black one. The number that's multiplied in the front describes the height. So when there's a 3 in the front, 3 times taller. When there's a half in the front, half as tall. C, negative 2x squared C would look like this. Mason, how come it's drawn upside down? What part of negative 2x squared do you think makes it upside down? Close. I mean, like, you're not wrong. The negative symbol itself makes it upside down. The 2 makes it twice as tall. So C actually has 2 changes. If you want to say it's skinnier, that's still correct. If you want to say it's twice as tall, 2 times taller, that's also correct. But then the second change is that it's upside down. And the upside down came from the negative. The weird part is that the negative and the number are separate. They do different things. And that's why I wanted to make sure to have that example in there. Okay, so when we get to the end of today, you guys are going to have to be able to do 2 things. You're going to have to be able to describe the transformation, and you're going to have to be able to graph it. So now that I've talked about the changes, I don't know if you caught on to the graphing part of it or not. So I'll describe that, okay? Remember how when I drew the original black one, I went over 1, up 1. When I drew 3x squared, I went over 1, up 3. So basically all I did was I multiplied the height. So instead of going up 1, I went up 3. On the purple one, instead of going up 1, I went up a half. The green one, instead of going up 1, I went 2. Obviously I went down because it was negative. So this number in the front only affects how far away you go. It's always going to be over 1. And then the second point is true as well. So the black one I went up 4. The red one I went up 12 because I multiplied by 3. The purple one I went up 2 because I took that 4 and I multiplied it by half. The green one I went down 8. So I'm multiplying the height by 2. See, Taylor? Taylor, do you have any Like, do you have a question, or are you trying to explain something, or are you just like, oh, you're definitely off on that one. Okay. All right. I will believe that for now. Okay, let's go on to the second kind of transformation, because there's two types of transformations. One of them affects how wide it is. One of them is going to affect up and down. This one is by far the easier one. Most people find this one very easy and very quick. I'll just politely say, if you guys are going to sit there and mess around with the Chromebooks, you should leave. Okay? So I get that you guys are like goofing around while the fact that I'm not in the room. I hope you get that when I'm back in the classroom, I'm not okay with that. And I'm hoping that you get that I'm not going to put up with it at all, because you won't be in the room. I 100% treat you guys as your own person, and I trust you, and you have my trust to start with. But if you lose my trust, then I'm not going to hold it against you, but I'm also not going to put up with it. So you are more than welcome to ask siblings or friends that I've had in the past. The thing that I stress is to treat everybody fairly and to treat you as your own person, your own adult. And I like to do that because you guys absolutely are your own person. But if you lose the trust, then I don't really put up with it, and I'm not going to hold it against you. But I'm not okay with it, and I won't have you in the room. So the fact that I'm not in the classroom, don't have me have a negative feeling associated with you before I get in there. Okay, so I'm going to start by drawing x squared first. So that's what we call the parent function. So 0, 0, over 1 up 1, over 2 up 4. And it works the same on both sides. So this is considered the parent function, the thing that we do, we base all of our changes from. Ugh. So we basically kind of memorize these 5 spots. Over 1, up 1, over 2, up 4. And that works on the right and the left. And those are what we base everything from. So this is the parent function. Now, if you have a number being added or subtracted at the end, that takes your graph and moves it up and down. So instead of being at 0, 0, this moves the vertex. So rather than changing the shape of it, like the multiplier changes how wide or skinny it is. If you add or subtract a number at the end, that changes where you start from. So we're going to start up at 3 because we add 3. And then up at 3 we go over 1, up 1, over 2, up 4. It's really hard to do looking at all these little squares. I think that's right. So you're going to have the exact same shape, but moved up or down. And if we have to describe the transformation, you literally just say up 3. Now, when you guys get to Algebra 2, there are actual words that mean up and down. And I don't care if you learn those now or not. So that's why I'm not, like, they make you say translate, because that means up or down. I am totally cool with you guys just learning what these things do to start with. Purple one has a -2 at the end. Who have I called on yet? Landon? Landon, what would a -2 do then, do you think? So I drew +3. How far? But you're correct. Perfect. So we start down at -2. So instead of starting in the middle at 0, 0, we start at -2. And at -2, I do those same points. Over 1, up 1. Over 2, up 4. So keeping these 5 points keeps the same shape. We're just moving our starting spot. And then we would say that this one is down 2. Like that's describing the transformation. So this is kind of what I was trying to say at the beginning of the hour, that once you learn what the things do, it's really simple to do the problems. But there's just, it feels like so much information that it's kind of scares them off. Okay, I don't know if you guys have any kind of questions on what I've done. Like, I'd be more than happy to go back up to this one and explain something again. The multiplier is usually considered more difficult. Or, I mean, most people think it is, just because of what you have to do. Moving it up and down, most people kind of seem to get or understand somewhat right away. So, I'd be happy to answer whatever. All right? Here's kind of the culmination of all of it, is they're traditionally combined. Like, normally you don't only have one change. They do the different transformations together. So before we graph them, and I'll give you a minute to write this down, because I know part of me forgets that I had it pre-written down, so it's like I kind of like move right on. I'll definitely give you a minute to get this written down. I want us to describe the transformations before we graph them. See it, Laura, is your Chromebook working kind of junky? You using your phone instead? Not a problem. I would agree. The Chromebooks are junk. If anything, this year has taught me to never buy my children Chromebooks. I mean, maybe they're good if you buy a good one. I don't know. But if you buy a good Chromebook, I'd rather just buy a normal computer. Does anybody have a good Chromebook at home? Do they like it? Like, does it feel totally different than the one you're using at school? My mom has one and loves it, but there's no way I'm going to take my mom's word on electronics. Okay, you've probably had enough time to possibly write some of this down. So let's look at the red one first. Somebody wrote something. Yeah, I agree. PCs are so much better than Chromebooks. It's actually Justice. I haven't called on Justice for a long time. Justice, could you tell me what either one of these two things do? So we've got a 2 there and we've got a -1 there. What does either one of those do? Or both, depending on what you know. How about the -1? That's probably more straightforward. what does the minus 1 do at the end? Yeah, that's definitely more technical. I was even okay with you just saying down 1. So that's 100% correct. So the minus 1 is going to move it down 1. Good. Ian, how about that 2? How would you describe that 2? There's different ways we can say it. What would a 2 do? You're correct. I mean, like, I think you might be explaining it right. How did we first describe a multiplier of 2, like in our first problems? So it's going to look, oh, that's all right. It's going to look skinnier or twice as tall. So when you say up, I mean, like, it is true, but describe it one of these two ways: skinnier or twice as tall. Both ways are okay. Okay, the 1 has 3 transformations. We have a minus, we have a 1/2, and we have a plus 3. So it's got 3 things done to it. Emilio, do you think you could give me what any one of those 3 things means? Your choice. Do you think you could tell me what any one of these 3 things does? The minus, or the 1/2 multiplier, or the plus 3? Nice, nice, very good. The negative means upside down. Ben, what about you? How about the 1/2 or the plus 3? Either one of those. What does the 1/2 or the plus 3 mean? So the 1/2 means it's, oh, okay, I got you. It's going to look wider, or it's half as tall. So kind of one of the hard parts is when we get to the unit test, like the chapter test, one of the questions is going to be for you to describe the transformations. And I'm trying to like model the words for you guys so that we can be specific enough that I'm going to know what you're trying to say. Because sometimes it's difficult to describe something, and you might mean the correct thing, but like it's just hard to find the right words. Okay, so then let's graph these. So let's do the red one. So I'm going to go down 1, and that's where I'm going to start from. So my vertex is down 1, and I'm going to draw it skinnier or 2 times taller. So I'm going to go over 1, and instead of going up 1, I double that, and I go up 2. I'm going to go over 2, and then instead of going up 4, I'm going to double that and go up 8. You think that'd be right there? So that's twice as tall. And then I'm just going to draw my mirror images. Like I don't have to like figure out more stuff. Right there. Because I know it's going to be symmetrical. So I can just draw my mirror images. I'm hoping you guys are better at drawing these than me because I'm real bad. It's really hard to make a nice line. I flat out did very poorly in art classes. I was not good at trying to draw smooth lines. I'm always amazed at the people who can. Okay, so that's the red one. Gladly I'll answer any kind of questions on the red one if you're not sure why I did something. Okay, purple one. I'm going to start with the up and down. So I'm going to go up 3, and that's my new vertex. And then this one's upside down, so I have to go down instead of up. Half as tall. So I go over 1, and instead of going down 1, I go half as far. So I go down a half. I'm going to go over 2, and instead of going down 4, I'm going to cut that in half and go down 2. And then I'm going to draw my mirror images. So this would be the purple one with those 3 changes. We only have a little bit left, actually. This is a majority of our notes. I was kind of curious if you guys could tell me how this is going. Like, I'm not going to be shocked if some of you are having a real hard time with this, but like, I'm just kind of curious where we're at for now, like 0 to 5. How are you feeling about this? The people I called on seemed like they were doing pretty decent, but I don't want to assume. Austin is an 8. That's interesting. Okay. All right. Well, a little bit all over the place, but that's not bad. That's kind of expected. Okay. How did you mean 3, 4, but you went 3, 4, 5, 6, 7, 8? All right. This is the second kind of question that you're going to get. And I don't know. I wasn't sure how you felt about it. Like, I didn't know if it would feel easy or not. Okay, what I want to do is I want to draw like a number line for you. Okay, regular x squared is the parent function. It's 1 squared. Remember when I had a 2 and I had a 3 and a 4? That made it twice as tall, 3 times as tall, 4 times as tall. Well, the bigger the number would make it look taller or skinnier. So the bigger the number, the skinniest it would get. Now the numbers that were smaller than 1, you know, like half, whatever, these were the ones that were wider. So the closer the number is to 0, the wider it gets. So when you're asked to put these in order from narrowest to skinniest, I said that totally wrong, narrowest to widest. What it's asking you to do is put them in order from the biggest number to smallest number, ignoring the negative sign. Because the negative only makes it upside down, and so that doesn't affect how skinny it is. So when it says narrowest to widest, this is what it's telling you. So I've got four numbers over here. I've got a 4, a negative 1/3, a 2, and a negative 1. Jesus. Phone is... ESPN is putting too much stuff out. So I'm going to put these in order from the biggest number, which would be 4x squared, and then go downwards. So my next smallest number is 2. And then the next smallest number is 1, because I'm ignoring the negative. And then my negative 1/3 is the smallest. Again, the negative doesn't matter. The negative just makes it upside down. So this would be in order from narrowest to widest. Okay, that actually worked out pretty good today, that we're relatively close to lunch. And honestly, that was a lot of information, so I'm sure your brain kind of needs a little break or rest here. I know nobody really asked anything, but do know you guys are more than welcome to ask for whatever help you want, especially when we come back from lunch and we start doing our homework together. That's a great time to ask questions, and you can just type them in if you don't want to ask them out loud. I don't mind answering them that way. Yes, if you're asking about when you're supposed to order them from narrowest to widest, yes. So make sure you guys are back on by 12:55. Yeah, Megan, got a question? Oh, nope.